Okay, thanks, Andy, for that introduction. And thanks, everyone, for coming out today. The Spark Summit in Europe actually sold out, I think, 1 or 2 weeks before the conference, which is really early. So we're excited to see all the people here. So as Andy was saying, there have been users of Spark in Europe from very early on, since the project started. And I actually remember the first patch we received for Spark from outside UC Berkeley, where we all were, came from Europe. It actually came from a gentleman in the UK who was helping make Spark work on Scala 2.8. So people have been using Spark here from very early on, and it was definitely time that we had a conference here. So I'm going to talk today about a few trends about how usage of Spark is changing and evolving, based on what we've seen happen in the past 2 years, because this is really when adoption of Spark really started picking up beyond sort of the very early kind of tech companies. And first of all, before I do that, I just have to say it's been a really great year for Spark overall. In 2015, Spark has continued to be the most active open source project in big data, which we're all super excited about. And it's gotten a ton of new features and improvements. One of the biggest ones is that we added support for a whole new programming language, which is R, which is opening up Spark to more and more types of developers and users. And finally, we've seen widespread industry support and adoption. I'm not going to talk that much about it myself, but you'll see, through all the talks that we have here, many of the different types of companies that are using Spark. And just to show some statistics about it, I just picked out a few measures of the community side. So first of all is the summit conferences. Last year, we held a summit in San Francisco. We just had this one conference, and we were really excited to have over 1,000 people. This year, we had 3 conferences overall here in San Francisco and New York, and in total, we've had almost 4,000 people. And because of the number of people we've seen come out with these, we're excited to continue having 3 conferences next year as well. If you look at a number of members of meetup groups on Spark, just from the beginning of the year, that also grew by almost a factor of 4. So there are now around 40,000 of them in meetups around the world, and many new meetup groups as well. And also, if you look at people contributing to the project, this has also almost doubled in the past year. And just 2 years ago, in 2013, this number was around 100. So this year, 600 people actually contributed patches to Spark, and we're excited to see that as well. And of course, we've done a lot of work to make it easy to accept contributions from a much wider community. So just to zoom in on one of those points, I'm just going to look at the meetup members. So these were the meetup groups at the beginning of the year, and these are the meetup groups at the end of the year. So you can see lots of new meetups, and actually quite a few of them in Europe as well, which is one of the reasons we wanted to have a conference right here. Okay. So finally, what does Spark offer? Why are people excited about it? Why are people actually using it? Basically, the way we look at it is Spark provides sort of 3 things that make it powerful, and that are the reason you see, all these different applications. So first of all, it's a general engine with libraries for many common data analysis tasks. So most things that you want to do with big data, you can find libraries for them on Spark, or you can implement it on top of Spark. And this shows up in the built-in libraries, streaming, SQL, machine learning, and graph processing. And you can just combine them together on top of this system. The second thing that makes it powerful is access to very diverse data sources. So Spark isn't tied to a particular storage engine, and over time, people have connected it to many of them. So some common ones are Hadoop, Cassandra, cloud storage systems like Amazon and OpenStack, and also traditional sort of SQL databases, and all of them can be connected to Spark. And finally, all of these are easy to use together through a simple unified API. So you just have to learn one thing to kind of figure out how to use all of them. So if you look at the activity in the project in the past 2 years, we've really focused on, basically expanding the strengths of Spark. So actually, most of the activity in the past 2 years has been in these libraries. All of those libraries, except for streaming, are actually new in the past 2 years, and we've spent a lot of effort developing these libraries to give people really good algorithms out of the box in Spark. And the data source, the support for more data sources is becoming more formalized now through the addition of this data source API in 2015. So we released that at the beginning of the year, and since then there are several dozen data sources that you can connect through this that all look very similar to you from a Spark program. So we're continuing to expand the engine in both of these areas. So what actually changed in 2015, or what are the trends we're seeing with respect to usage? I'm going to show some information from a survey that we ran this summer, and we ran a pretty large survey of Spark users. We had 1,400 respondents from over 800 companies, and we run actually a similar survey every year, and I'm just going to show some of the stuff that's different from previous years. And basically, overall, we see three interesting trends. First of all, we see an increasing diversity of applications, the types of organizations that are using Spark, and also what they're using it for. We see more runtime environments, more of these data sources that I talked about earlier. And finally, we also see more types of users. And we've been working pretty hard through things like the R interface and improving Python and so on to make Spark accessible to more, more types of users with more kind of backgrounds. So I'm just going to dive into the first one. So if we look at, what kind of organizations are using Spark, Spark actually started out mainly being used in tech companies, web applications, mobile, and so on. But today, it's actually a very diverse map of organizations that are using it. So we still have the biggest, box in there. The orange one is the web and mobile one, the software one, which makes a lot of sense. But we also see actually kind of a comparable sort of total for other types of industries. So things like banking, finance, computer hardware, education, healthcare, and so on. And we see actually, use kind of in pretty much most sectors of the enterprise space. So we're really excited to see this, to see people actually applying it to these different kinds of use cases. And you're going to see talks at this conference from several of these companies in different areas. So I think there are at least 3 financial companies. There's a talk from a telecom. There's talks from 2 companies in education as well, and many others. And basically, you'll get to see how it's being used. And in terms of the actual applications, here are the top actual use cases that we saw. So business intelligence and data warehousing are the first 2, and it makes sense because nearly everyone who collects data just wants to compute some basic reports about it, which is the business intelligence part, and actually load it all into the same place and manage it together, which is data warehousing. And then we see more advanced applications like recommendation engines, log processing, user-facing services, fraud detection, and so on. And basically, these are also spread out across the different industries. So people are doing a little bit of each of them. And the final thing I want to show about applications is which components of Spark are being used. So the thing we're excited about here is all these new libraries built on top for these different types of processing are actually used quite heavily, even 1 or 2 years after they've come out. So Spark SQL and DataFrames really came out basically middle of 2014, beginning of 2015, but they're already used by over 60% of the users in this survey. And streaming and advanced analytics, which are some of the more advanced things, also come up in close to 60% of the use cases. So we're excited to see that people are actually grabbing these new things and using them in applications. And another exciting part is that most organizations use more than one of Spark's components. So they use 2 of the libraries together or something like that, which is exactly one of the things that we wanted to enable. by giving you all the libraries in the same kind of platform. Okay, so that's kind of it for some of the trends in applications. So next thing I want to talk about is diverse runtime environments. And this is one of the things that we tried to enable in Spark from the beginning, and that also set it apart a little bit from the kind of big data processing platforms that existed before. So we're excited to see this increasingly being a factor in how Spark is being used. So often, a lot of people ask, what is kind of technically different between Spark and Hadoop, for example, there's like details of the technology. But one of the things I say, which is maybe less obvious at first, is also the separation in Spark of the compute from the storage. So in the Hadoop stack, which was there before, you had a single platform that combined computation and storage. And obviously, this is very powerful if you just want to manage a bunch of clusters together and get them to do things. But it basically meant you had to use both of the pieces of the stack. You had to use the HDFS storage, and then you could do computations on it. In Spark, we wanted to just build a computing engine. We didn't really want to do something in storage. So we designed one that can plug into many different storage layers. And we still use the same efficient interfaces that MapReduce uses to connect to HDFS. So we can get things like data locality and things like that. So we still get the same performance when talking to that storage. But we've opened up the storage plugin to talk to different ones as well. And so you also see a lot of NoSQL databases, things like Cassandra, and even things like SQL databases that you can connect to Spark. So this is one of the things that was just enabled by the nature of the project. And we're excited to see this come up in use of it as well. And as one example of that, I'm just going to show some of the data sources that people use with Spark. We asked, for different data sources, which people use them, and do they use it a little, do they use it a lot? And basically, in 2014, Hadoop was by far, the most widely used data source, and it still is widely used now. We had about 60% using it a lot, 30% at least a little bit, only 10% were not using it at all. In 2015, though, we see Hadoop is a smaller fraction of the overall pie. Of course, the total number of users has grown, so it's still a large number of total users. And we also see NoSQL and proprietary SQL databases, which are sort of heavy-duty kind of data warehouses out there, are increasingly becoming, kind of on a similar magnitude of usage. So they're all around 40%. And basically, this shows, it makes sense to connect Spark to these other data sources as well. And the final thing I wanted to show about runtime environments is where people actually run it. And here the numbers also kind of match the story I've showed before. So in terms of cluster manager people use, about 40% on Yarn, which is the Hadoop cluster manager. But we see quite a few people running Spark kind of on its own as well, which is usually the case with other data sources. And another thing we're excited about, especially at Databricks, because we are a cloud company, is increasing usage on the public cloud. So now this year it's actually hit more than 50% of the usage. And the public cloud is definitely an environment where you really want to separate compute from storage, because you can scale up and down computing elastically whenever you want. So it makes a lot of sense to do that. And final thing I wanted to talk about a little bit is the diversity of users. So there are many ways to measure that, but definitely a major drive we've had is to make Spark easier for more types of people to use, both more software engineers and developers, but also new roles like data scientists, data analysts, and so on, who are not necessarily programmers as their main 100% job, but want to be able to use the data in these clusters. And to show that, I'm going to show a little bit about, first of all, about the programming languages used. So this was the results in 2014, how many people are using each language. And basically, in 2014, we saw Scala is by far the most popular choice, especially among developers. It makes sense. It's a good combination of speed and being high level and easy to write code in. And we saw Java and Python were each around 38%. So this was 2014. In 2015, this is what the picture looks like. And there's a few kind of interesting changes. And of course, remember, this is with a lot more users. I'm estimating at least 2 times, but probably a lot more than that, actual new users. So Scala is still very high, 70%, and it's still a very common choice among new users. Java is roughly the same as before, but the interesting thing is the increase in these sort of higher level scripting languages. So Python grew all the way up to 58%, and then R, which is new this year, it was also kind of high enough at the time of the survey to be noticeable. So we're really excited to see these things, and we've designed a lot of stuff in Spark to make it easy to combine these languages as well, so that you don't have to pick one or the other, and whatever code you develop in Scala and Java is also accessible, for example, to the people using R. So that's one of the things that we're excited to see. And second thing I want to show here is some of the other fast-growing components or trends we're seeing in the usage. And so one that I'm sort of excited about is increase in Windows users. As Andy said, this actually grew by almost a factor of 4 this year. I think around maybe 23% of users now say that they're developing applications on Windows. And I'm really excited about this personally because I'm the person who added support for Windows at the beginning. And let me tell you, it's not fun. Writing Windows batch scripts and stuff, it's a very interesting language and system you have to use. So I'm excited to see this there, although I hear there are still a few problems with it. So those, those are not my fault. Okay. Next, we see streaming. So this is a production user. So this is not just kind of prototyping an application, but production. This grew by a respectable sort of 50%, and we're excited to see, basically more of these applications going into production. And the other thing that has very quickly grown in production usage is SQL. And SQL, of course, was new last year, so it makes sense to see significant growth of that as well. So these are some of the new use cases. And SQL also ties into the more diverse users because, of course, a lot more people know SQL than a programming language, and we see a lot of people using Spark this way. All right. So that's like a few quick statistics on how usage of Spark is changing this year. So given all this stuff, are we done? Can we call it a day? Of course, the answer is no. And actually, development in the open source project is going faster than ever. So I just wanted to talk a little bit about some of the new technical things going on, and there'll be quite a few more talks on these, today and tomorrow. So from a technical side, the biggest kind of change, in my opinion, that came out this year was DataFrames. So DataFrames are interesting because they give you, a language-integrated API. You can use that in programming languages, but they move many of the computations over to the Spark SQL engine, which understands a lot more about the computation than the traditional Spark engine did, because it knows it's a relational engine. It knows about tables and schemas and expressions that you run on those tables. And DataFrames are interesting both from the API point of view, but also from optimization that we can do in the engine. And we're doing a lot of that now behind DataFrames with this effort called Project Tungsten that is trying to make Spark use modern hardware more effectively, so both memory and CPU. So on the new API side, things like the R API to Spark is completely based on DataFrames. That's actually the main way you work with data in R. And also new APIs in Python and in the machine learning library are using them as well. And on the optimization side, we already have the first few bits of Project Tungsten that came out in Spark 1.5 that make these computations more memory and more CPU efficient. So what is different in DataFrames than traditional Spark? This is sort of just kind of a quick look from the technical side. So basically, in the traditional Spark API, you had user code and you just wrote kind of arbitrary functions in Java or Python or the other languages, and you hand them on these RDDs or distributed data sets, and then they just executed on top of opaque Java objects. So it was nice because it's very general, but it also meant the engine doesn't really know much about the code you're running on and the data. And it's really hard to make something that's efficient for arbitrary Java objects or that understands all the Java functions out of there. So it kind of limited what we can do. In DataFrames, this changes a little bit because a lot of the API is based on expressions, so it's a more limited type of functions that you're running on there, where we can look inside the expression and see exactly what you're doing. And then DataFrames come with an optimizer, the SQL optimizer we have called Catalyst, that can move those expressions around and push them up and down the tree and get a more efficient execution plan, which is something we couldn't do before. And the final thing that DataFrames enable is we know the schema of the data, and we can do schema-aware storage, like, for example, in the in-memory cache, and we can also push queries down into data sources. So a key part of this data source API that I talked about is the ability to push queries into each storage system and do part of the query in there to make it more efficient than just slurping all the data out at once. So these are some of the things that DataFrames enable that will make programs faster and also more powerful. So we're excited about how well DataFrames have worked so far, and we want to extend some of these advantages to the rest of Spark. So one of the things that's coming in Spark 1.6 and that you'll see in a few other talks is a new DataSet API that's basically a typed interface over DataFrames. So if you're a programmer, this means it's a statically typed interface, which means you get something that is easy from a software engineering point of view because you know the types of data everywhere, but you get some of the advantages of DataFrames underneath. And this was a common thing that a lot of developers asked us about when they saw DataFrames. They said, hey, can I use this but still keep static typing and actually be able to build really large programs? So here's an example of that. You could define a class in Scala, like a class that represents a person with a name and an age. And then you could read, say, a JSON file as a data frame. That's a thing we support in the data frame API. And then you can cast it to a data set of person objects. So you can say all of these have a name and an age, and I want to view them as this class and pass them around my program that way. And then once you have that, you can start running kind of functional operations on this that view each element as a person object, so filter out by name. Or you can also run the data frame operations we have, where you just give expressions, so group by name or average of age. So you can actually mix these two things. And there'll be the data frame talk today by Michael Armbrust will cover a little bit of what's happening. This is going to come out in basically a month or two in Spark 1.6. And so other things that are in the works, we also would like to integrate DataFrames with the graph library and streaming, again, to be able to combine these benefits of the relational kind of engine and the nice language integrated APIs. And we have some ideas on how to do that. You can see some of them in the online sort of issue tracker. We have a lot more work happening in Tungsten, so faster in-memory cache, support for storage on SSDs, and better code generation are some of the things that are currently in the works. And we'd also like to extend this concept of pluggable data sources to streaming, so you can write a streaming program that doesn't care too much about where data is being read from and where it's being written to, and it looks the same regardless of what you're using. You'll see Reynolds talk tomorrow morning for more details on some of these things. He's going to give more technical talk on what's happening next in Spark. So we're really excited to continue evolving Spark and to meet these two kind of goals I mentioned earlier of working with many different data sources, giving you a common way to access those, and letting you do many different types of computations efficiently. So that's it. I wanted to say danke, I guess, in the local sort of way of saying it, and enjoy the rest of the Spark Summit.